A very good day to one and all who are present here. Since we're in different time zones, I don't know if it is good morning, afternoon, or evening, but a very good day to one and all present here. This is Gerard Deepak, a research scholar from National Institute of Technology, Tiruchirappalli. I'm here to present the paper titled LWOntoRec, a lightweight ontology-based novel diversified tag-aware song recommendation system. I'm presenting this paper on the behalf of my co-authors as well, who's Sai Charan and Dr. Santana Vijayan A from NIT Trichy. So the abstract. So as the term indicates, the proposed system is a knowledge-centric, diversified, tag-aware song recommendation system. So recommendation systems are definitely the key in the era of semantic web 3.0, as web 3.0, which is a semantic standard of the web, or which is the web of data, is the vision of Sir Tim Berners-Lee, the father of semantic web. And we are currently moving very quickly towards web 3.0, and maybe within a decade or much even less than that, the entire web 2.0 will be transformed into the semantic standard of the web. So henceforth, we must require semantic compliant recommendation systems. So this approach is an intrinsic mechanism to eliminate ambiguity and embrace contextualization in a highly dense, cohesive environment like the web 3.0. So the ambiguity of search, especially the tags as well as the songs, is eliminated in the proposed approach. A semantic slot filling strategy that encapsulates a social spider for tag diversification and thereby facilitates in recommending songs has been proposed. Yes, in this approach, a semantic slot filling approach by using semantic frames has been proposed. So the approach does not use an ontology as it is. Rather, it uses knowledge as well as ontologies in the form of semantic frames, as well as RDF. Okay, it uses, and the video recommendation systems makes use of frames for implicitly reasoning out and yielding a full cover diversification of tags, which reduces the ambiguity and enhances the contextualization of tags, and thereby recommending songs in the social web environment. Of course, this is also a socially aware system. The reason is because it uses a Twitter API, which we'll be discussing in the further slides. The proposed LWOntoRec framework exhibits an overall F measure of 89.27% with a normalized discounted cumulative gain of 87%, which makes it a full cover search with a very high relevance rate. Motivation, yes, need for a lightweight semantic compliant recommendation system. Yes, okay, lightweight as in the strategy must be inferencing. It should not be learning, because learning from the real world Wide Web, okay, the World Wide Web data is too extensive, too massive. It is not at all, feasible to train the entire system using the data contents on the World Wide Web. It's very difficult. So rather, the semantic web strategically organizes the web. So since there is a good amount of taxonomy and knowledge on the web, okay, a lightweight inferential based semantic compliant recommendation system for both songs as well as tags is required. Necessity of an approach which recommends items based on diversification of the recommended results. Yes, since we are using standard knowledge based repositories, which we'll be discussing, okay, there is diversification of results. So diversification of results means we are enhancing the diversity of the search, and which clearly indicates that the serendipity problem is solved. So users will have more choices to select upon, because there will be a full cover of the queries which will be triggered for and the recommendations will have a full cover recommendation. An approach which uncovers hidden concepts based on derivation of derivational rules is essential. Yes, that's what we are proposed here. A system which would recommend songs based on diversification of real world music class, has been proposed with inferencing as the primary goal. Yes, we are not making use of learning, but we are making use of inferencing as much as possible. We are reducing the computational load by eliminating learning itself. That's why this is a tag aware video song recommendation system. An approach based on semantic frames and derivational rules for tag diversification has been proposed. The approach uses ontological elements but expressed as frames and derivational rules to aggregate entities from various heterogeneous sources and specifically real-world knowledge sources. A social spider algorithm which is semantically aware has been proposed for selection of tags based on optimization using the web PMI model for selection of tags that are derived based on the existing rules, which is nothing but the derivation rules. An accuracy of 87.05% has been achieved with an NDCG of 87%. The trade-offs between diversity and relevance was achieved for recommending tags as well as songs of the proposed approach. Existing works and the issues. Firstly, we do have the Gaussian space model approach. So the Gaussian space approach is a very traditional approach. Semantic labels are used here. Okay, in order to enable user item interaction over sparse data. But Gaussian space model is time sensitive, and moreover, it does not yield results which are satisfactory, and computing is difficult when it is a Gaussian space model. Attention based by LSTM approach, of course, yes, attention based LSTM. This learns a deep semantic meaning, okay, for inferring relationships between previous objects accurately. But the problem is the training. When it's not possible to have this system implemented in real time. The reason is training from the existing data on the World Wide Web. That with auto handcrafted feature extraction of the by LSTM. Definitely the training is a problem, and henceforth the by LSTM does not yield appropriate results. Line optimization and collaborative filtering approach. Yes, collaborative filtering is mainly for recommendation systems, but most of the song recommendation systems do not have ratings. Of course, there are ratings for artists, and these ratings can be biased. And also, when collaborative filtering is the core approach, the system would suffer from the cold start problem. This is why this approach is also not very feasible. There's a lag. And binomial framework approach uses greedy technique for optimization. Yes, okay, it's a very traditional approach. Objective function is used, auxiliary knowledge is used, diversification of tags is obtained, but this is just a tag recommendation system. While it did perform well in the yesteryears, this definitely can be improved. So our proposed work is on a similar lines, but it is semantically driven. So the architecture, so the user profile as well as the user intents which are captured. User profile is the historical web usage data of the user, the history contents, the browsing contents of the user, as well as the current user intention, the user clicks, is formalized into a query topic. And this query topic which is formalized, okay, this query topic which has been formalized is used for semantic frame matching from the data set. So semantic frame matching is discussed later by using derivational rules, which will be dealt upon. The data set is a song recommendation data set. So therefore, derivational rules with respect to several attributes and parameters for song. We know about song recommendation. We must require the title of the song. We must require the artist, the genre, etc. So therefore, since we know all the parameters which is required for recommending songs, okay, it can be matched as a frame, and then this can be used to fill some empty slots. This is what is done, which will be discussed in the later. That's called slot filling approach. And then query topic tag intensification happens. What is tag intensification? Okay, tag intensification is by matching the query topic formalized query topics and the appropriate labels as well as categories in the data set. So tag is intensified. Now this intensified tag is fed into the socially aware, semantically aware social spider algorithm for tag recommendation. Okay, of course, yes. Okay, so these tags as well as the tags, okay, which is extracted from several, okay, real world knowledge bases, like we do have several recommendation systems, okay, song recommendation systems like YouTube. Even in Amazon, there is we can recommend, there is a part where songs, there's a portion where you can you can get the playlist, etc. The Netflix, Twitter, IMDb. Okay, so these are the different heterogeneous knowledge sources. Along with this, song specific websites like the billboard.com, etc. has been incorporated. From this, okay, the data is extracted in the and stored in the form of a RDF store in the form of SPO, subject predicate object format. So based on the items in this RDF store as well as the query topics in the from the tag intensification, okay, the social spider algorithm, which okay is computed by using the PMI as the objective function to yield the most appropriate tags, and based on these tags further, okay, by matching it with the data set, okay, the categorical contents in the data set, the songs can be recommended. Strategies incorporated. We do have the point-wise mutual information strategy, PMI, which is used. PMI is a very traditional mutual information, okay, for computing the semantic similarity between a pair of terms. The reason why we are using PMI or the web PMI is because it is very simple. Firstly, secondly, it is governed by a social spider algorithm. This is an objective function. So when social spider along with PMI is incorporated, it gives very good results. Okay, so that's one of the reasons why, in order to make it computationally less expensive, we are using the PMI model, okay, embedded in social spider algorithm. So these are the derivational rules, okay, which is these are the derivational rules which are modeled as a context-free grammar. For example, we know that for song recommendation we require the parameters are known, like language, genre, artist, rating, style, etc. So we are modeling the CFGs, and this is a slot filling. For instance, if it's language, automatically it will fill the slots based on the data set. Like we have English, Tamil, Telugu, Hindi, Kannada, Spanish, French, etc. Title, immediately it'll get the title like cardigan. What do you mean? Title of the songs, genre, whether it's folk, classical, rock, party, or what kind of a categorization it would be. Okay, so this is how it is. The strategies are incorporated. Implementation, yes, we're using the last or FM data set, and semantic frame matching is initiated by computing the semantic similarity between the categorical data set. So each track comprises information about the artist, title, timestamp, similar tracks, and tags. Data set is available in the raw format, representing each track as a JSON object. It consists of 94, 33, 47 match tracks, 50, 52, 16 tracks with at least one tag, and 522366 unique tags. And track similar track is 56, 506, 688. Okay, it's really large to quantify it. The user intentions are captured based on the current user search themes, topics, and genres. We are formalizing the query topics by aggregating term from the user click, that is a web usage data, the current user click of the user, and the terms from the web usage information of the user. Finally, based on the frames formulated, query topic tag intensification is done by including a closed word semantics. The term is missing here, I'm sorry for that. Knowledge base that has been generated from DBpedia, Wikidata, and other websites like billboard.com, IMDb, etc. has been proposed. Semantic aware social spider algorithm for optimization of tag diversification, and in turn, okay, diversification of and recommendation of songs has been achieved. This algorithm, it's very clear. You can see it's divided very clearly. Here in step 4, it is all about slot filling by using the context-free grammars, thresholding, semantic similarity matching. All of this happens here. In this case, here towards the right side, 5.1 onwards, it's all about the social spider algorithm. How exactly the social spider algorithm is incorporated into the specific approach. This algorithm is almost on the same lines as the architecture. So henceforth, I'm not going to waste much time on this. Evaluation. The performance is evaluated using precision, recall, accuracy, F measure, and the normalized discounted cumulative gain as a potential metrics. Apart from that, we do have other metrics like coverage and FDR we'll be discussing. I think NDCG and FDR. Yes. Yes. Okay, but these are the 4 major metrics. So NDCG is so here the average NDCG for various baseline models. We do have only one baseline model, which is proposed by Vijay. It yields an overall NDCG of 0.81. Whereas, okay, but the proposed hybridized strategy yields an NDCG of 0.87, that is normalized discounted cumulative gain. So without the auxiliary knowledge, it is, yeah, when knowledge is not given, automatically it drops down to 0.74. When social spider is not incorporated, it is 0.79 alone, the NDCG. When user profile based personalization is not incorporated, it is only 0.73. The base paper gives 0.81, the binomial approach, yes. So henceforth, okay, the proposed hybridized strategy yields a higher NDCG, higher normalized discounted cumulative gain means higher coverage. Higher coverage means higher relevance. Higher relevance means lower ambiguity, lower context irrelevance, and which means it is a full cover semantic search. And the proposed approach yields an accuracy of 87.05%, precision of 89.53%, recall of 89.02%, F measure of 89.27%, and NDCG of 87. 87%, yeah, it's 0.87 or 87%. Further, performance comparison with respect to accuracy versus number of recommendations is very clear that, okay, as the number of recommendations increase, okay, so for every point, okay, the hybridized strategy is much higher, be it, but as the accuracy number of recommendations increase, of course there will be a slight dip in the accuracy, but that doesn't matter because for almost all the systems, okay, the behavior is the same. But the main thing to note is the proposed strategy is much higher than the other variations of the proposed strategy, and okay, and the base paper. The variations are done because this is a hybridized strategy, which is an incremental approach wherein there are many approaches which are encompassed and hybridized together. The reason why the proposed approach performs better than the other approaches and the base paper is because auxiliary knowledge is supplied, okay, knowledge from real world knowledge sources like YouTube, Twitter, which makes it semantically aware, socially aware, Twitter API, okay, YouTube, Amazon, IMDb, Billboard.com, and other sources is integrated into the approach. DBpedia, Wikidata, all these kind of knowledge sources, knowledge is extracted and it is induced into the approach so that the proposed approach yields a higher performance, higher NDCG, and higher accuracy and higher F measure. In the base paper where he uses a binomial approach, it's a very traditional approach. Though auxiliary knowledge is supplied, but there's a scope. The sad part is when LSTM or when GRUs were used, that is when learning was incorporated, let me tell you that the performance did not even reach, the precision did not even, accuracy and precision did not even reach 75%. So it performed worse than the binomial approach. The reason is because training is difficult. Okay, and training based on the knowledge is very, very difficult, but inferencing is really easy because, okay, and social spider helps in optimization. That's one of the reasons why the proposed approach is yielding higher amount of accuracy, NDCG, precision, recall, and F measure. Conclusions: a lightweight knowledge-centric approach to diversification of tags and thereby recommending songs based on the semantic frames and derivation rules has been proposed. The incorporation of several real-world knowledge sources and also the Twitter API ensures the proposed approach is socially aware. It is semantic and socially aware, which is really good. Amalgamation of semantically aware social spider algorithm for optimally selecting the tags based on the derivation rules has been proposed. An overall F measure of 89.27% has been achieved, which is the best in class performance with respect to several existing song recommendation systems. Ultimately, the performance is evaluated for the recommendation of songs. If the NDCG, precision, recall, and accuracy is evaluated for the songs recommended, but songs are recommended based on the tags. So these are the references, and thank you for your patient listening, and thanks for your time. If you have any queries, kindly write to me on gerard.deepak.cac.nitt@gmail.com. Have a nice day and happy holidays and Merry Christmas.